Welcome at PASC23 on stage. I'm here with Luigi del Debbio from University of Edinburgh and Sinead Ryan from Trinity College Dublin. Fundamental Physics is here today, and we want to ask you, so you had the mini-symposium at this PASC conference. What was your mini-symposium about?
So the mini-symposium was basically on how to take advantage of the new machines, the new architectures that are becoming available to scientists in order to foster our research program in fundamental physics. So how to produce, sort of better and more relevant results at a time when experiments are running and producing experimental results. So try to foster the link between theory and experiment and push forward in our understanding of fundamental physics.
Sinead?
So it's a challenging time, I think, for particle physics. So we really need extraordinary precision now to make progress. And so Lattice QCD plays a fundamental role in broadening or deepening our knowledge of particle physics. And so we talked a lot in the mini-symposium about what might be achieved with new machines that are coming on stream at exascale and with the new technologies like AI, and how we can integrate those new paradigms into how we do business every day in Lattice community.
So after the presentations and the discussions, what are the take-home messages?
I think one very clear take-home message was that machine learning ideas, AI, is really here to stay, and this is something that's going to be very relevant for our field. And there's a lot of work that's going into understanding how we can incorporate it in the most expensive part of our calculations, which is the gauge field generation, but also more generally into our workflows in the lattice calculations. And we need to do that in an energy-efficient way.
Yeah, and I think it was particularly good actually to be here at PASC because of the interdisciplinary sort of aspects of this conference. So it was really good to be able to see how these problems are tackled in different fields and to be able to talk to actual scientists that are engaged in this kind of problems. So yeah, no, this was an excellent environment for this kind of discussion.
What are the next steps for in your opinion, to move forwards, and what would you like to see, for example, if you again submit a mini-symposium next year at the PASC conference?
Well, I think the main issue for us is to move from ideas to actual algorithms that work. So I think there is a lot of activity in our field at the moment. So ideally, I think it would be nice to be able to sort of get these people together and be able to present another mini-symposium next year with more results and less sort of ideas.
Yeah, I mean that's exactly right. We're at a very early stage, so we're trying lots of things in toy models, you might say, not in the sort of real theory, the QCD theory that we want to simulate. So yes, and next year, let's hope that we have some real results.
So Lattice QCD is known for being able to use any system on the planet and use as many resources as are available. So what more?
More. So we will, I hope that we will be able to continue, to use efficiently all the resources that are available, to use increasingly more cycles. And I think the new angle, which we started discussing this year, is to be able to do it in an energy-efficient way, which I think is becoming an increasingly important concern in our field.
Absolutely. It's not going to change, Maria Grazia. We'll still jump on every machine that becomes available and use it as much as we can, I think. But aware of the fact that we need to do that now with new ideas on board.
So thank you very much, Luigi and Sinead. It is always a pleasure to talk to you, and thank you all.